My title is Director of Open Scholarship Strategy at Stanford University. I'm also the Director of the Open Source Projects Office. I've been at Stanford for 20 years. I started out in academic computing in the libraries. Then I did a tour with Stanford University IT, heavily involved in Drupal and open source there for about 5 years. And I moved on from that to our office of the Vice Provost and Dean of Research. So all of those are different professional lenses. So I kept all of those networks. So when I started with the Center for Open and Reproducible Science, which is my current center, that's part of the network building that I'm going to talk about in a second. So Stanford University is in California. Actually, some people think it's Palo Alto. It's not. It's an unincorporated part of Santa Clara County, so it's sort of like its own city-state. And sometimes I joke that it has its own bank, police force, hospitals. It's actually built on bedrock, so like literally bedrock. So I kind of joke sometimes that even if California were to like fall into the ocean or earthquake, I think Stanford would still be sitting on some sort of rock promontory in the middle. It's a kind of a strange place. In many ways. So there we are. There's Palo Alto. So this is smack dab in the middle of Silicon Valley. And so that's not by accident. Stanford was part of the origin story of Silicon Valley. You couldn't have had something like that without a research institute in the middle. But the other things you need are money and lawyers. So I don't know if you can see here. I think it's a little, but just here, this road is Sand Hill Road. So that's where, at the top of this hill, that's Andreessen Horowitz, Kleiner Perkins, Greylock. So this right to the west of the university is probably the largest concentration of venture capital in the world. And the others, so you might hear about that address, Sand Hill Road, but the one you don't hear about is Page Mill Road, right here. That's full of law firms that specialize in launching startups. So WSGR, so this is all money, this is all lawyers, and this is all research. So that's the recipe. So that's the strange environment that I find myself in. So the center that I'm part of is the Center for Open and Reproducible Science. We've been around for about 6 years now. The leadership team is off to the right. So Russell Poldrack, he is a leader in neuroscience. So you may recall the reproducibility crisis that came to a head in the mid-2010s. So psychology was one of those fields with underpowered studies and irreproducible results. So my boss basically decided to roll up his sleeves and set himself to that problem. So his lab is one of the leading labs in the world in this area, reproducible neuroscience. They invented the brain imaging data standard that's now used around the world and throughout industry, and also the Open Neuro data sharing repository came from that lab. Maya Mather, my associate director, and Matthew Raskoff, he is the associate director for open education with us, but he's also vice provost for digital education for Stanford. So we have several initiatives going on in our center. So open science is our context. So there are different kinds of OSPOs, right? Some are situated in tech transfer offices. We're situated in a center for data science and soon to be merging with our AI Institute. So several key activities. We've got the OSPO, which is probably the bulk of my work. We have an annual symposium, which is the major convening, bringing together this disparate scholarly community around Stanford and beyond. If you happen to be in the Bay Area, that's April 29th. We'd love to have you. One of the challenges we have in open science is recognition and reward. This isn't something that the Academy typically does by itself. So if you want people to share data and share code, you have to recognize that and elevate that work. So we do that by presenting awards to deserving scholars to sort of have an acknowledgement of that. We also write those distinctions to working records, so it's a permanent CV marker. So we have other activities. So we're looking to disrupt the publishing industry in textbooks. So we're partnering with MIT Press on that. It's an initiative called Living Textbooks with GitHub-based textbooks. And we perform workshops and consultations for faculty. And we're also engaged at the national level in the US for open science policy. I'm the coordinator for Helios Open, and we're also interact with the national academies. So that's the context of our OSPO. And here are our faculty affiliates. So this was the first real coup that my faculty director pulled off, and that is each of these people. So these are all Stanford faculty, so that represent every school at the university. And so these are champions within their field, but all coming together to share practices. And there are some really astounding people here. So I don't think I have a pointer on this, but this person right here, this is Allison Marsden. So she is a professor of engineering and pediatrics. So her work involves taking engineering models for the way that fluid dynamic models and applying that to the human circulatory system in such a way that, so she's partially appointed to the hospital. This makes it all the way to clinical interventions. So she has the vascular model repository, and her open source project is SimVascular. So they're modeling the human circulatory system in ways that doctors actually use to choose interventions for a given patient. So the data ingest involves data about targeted for the patient, specifically pediatric surgery. So just so every single person on here is a revolutionary in their field. Gretchen Daly at the top, so Percy Liang all the way on the right. So this is the person that coined the term foundation model. So he invented Helm, the holistic evaluation of language models, and a lot of the work of truly open source AI that Stanford is producing is coming from his lab right now. We have the pleasure of working with all these folks. So this is just a tiny, so Stanford has 2,300 PIs, 2,500 postdocs, 8,000 grad students. Everyone is writing code. Every single one of these research projects. The vast majority are either in Python or R, but it's all open source for the most part. Because the policy at Stanford is that no one has to ask permission to open source their work. So that means it's, as an OSPO, it's impossible to keep up with. So again, I'm just sort of painting you a picture of what it's like to try to keep up with these folks. So university OSPOs, I think we're all grateful to the Sloan Foundation for seeding this idea. So the Alfred P. Sloan Foundation decided that it would be interesting to find out what would happen if the university had an OSPO. So we're grateful to them. And the other thing that I'll express my thanks for is the openness for a hypothesis-driven approach, where we had a bunch of ideas about what we thought was going to be impactful at a university when we started. But then we got started and we learned this. So we've adapted. And so, and I think that's why we also have the speciation with the different types of OSPOs, because we're all reacting to a local environment and the opportunities are going to be different at different universities. And that's good. The second thing we had to figure out was, can we actually help these people? So in terms of overcoming imposter syndrome, Stanford computer science faculty and grad students are among the most accomplished in the world, and who the heck are we? Can we even help them? And so it turns out we can. So they are, there are some that are always they're gonna be on a rocket ship and they don't need our help. I was just talking with somebody in the hallway about Together AI. That was 2 Stanford faculty that got together, founded a company, and now it's worth, I don't know, $4 billion or something like that. Annual revenue over 300 million. But if you do want to do work in, open models, that's, they're a, AI top 50 company. Are we going to be able to help them? Probably not. But I did, in fact, have a call with Percy Lang the other week, and I was like, oh my God, I get to talk to this person. The part that they're missing, all of them, is that no one teaches you how to do community. And what makes open source great is that it's participatory, and community makes these projects stronger, and no one kind of coaches how to do that. When you're getting your PhD in a scientific discipline. So that's a way for, I would say, an OSPO at any university to show up and help, because of our group, I would say half of them want to attract external contributors, but they don't really know how to do that. So some of our current activities, one of the hardest jobs is just figuring out what all is happening at this place, because with no gatekeeping function, how do you know the projects that are happening here? So we decided to stand up what we call our projects registry. We made it public. So if you go to opensource.stanford.edu, you can see those. So how do you make decisions about what to include? We asked them. So we asked the faculty and the research community what they thought was notable. And then I'll skip over to the fourth thing here, the prize. So this is one of those things that we didn't imagine doing at the beginning, but Josh let us do it anyway. So of the projects listed in the registry, we award a prize annually, the Stanford Open Source Software Prize, and you'll be blown away with how people respond to that. So recognition of your peers and recognition that this is noteworthy, this is good. Of all the possible things we could have chosen, the reaction to that is astounding. Oh, and by the way, you can only be considered for the prize if you happen to be in the registry. So all of a sudden people but this second one here, maintainers and contributors roundtable, that is the gem of our OSPO. So what we found is that in every lab across the university, there's usually a coding lead. Now, this can be a graduate student, this can be a postdoc, this can be a professional research software engineer who came from industry. The expertise range is vast, but frequently they don't have a peer. They don't have anybody to go to work things out. And just by building a place for them to come that's open, welcoming, supportive, and where they can share struggles and techniques with each other, true community of practice, they respond to that. So the leads of these labs, computer science faculty at Stanford, they're all also CEOs of companies and things like that, on various boards or whatever. They're not going to respond to you or to me. You solve problems for their postdoc, you solve problems for their research software engineer, suddenly they'll talk to you. And also, it's just in terms of the impact we're having, in terms of moving the needle at Stanford, that's one of the best we've done. And we do workshops and stuff. That's not super interesting. We started out with baseline workshops around open science best practices, but then we quickly realized we kind of hit our expertise limit. So we've partnered with external groups. So if you ever heard of PyOpenSci for the Python community, or ROpenSci for the R community, they are wonderful. I would look them up. And so we decided to partner with them for our workshops. The other thing that we're learning is that the university thinks of itself a certain way. It judges itself according to certain metrics, but open source is largely ignored. And that's a huge mistake because the software that we're producing has a huge impact on the world. It's another way of looking at what we produce as a university. So typically we'll look at publications and we'll look at awards. And we'll look at companies, and NSF wants to know how many scientists we're training. But this is a whole other impact scale. It's kind of a green field way of presenting this information back. And it's also another, so it's very hard to get into universities like this, but every single GitHub repo is an offer. So one of the things our OSPO tries to do is help these science projects build a contribution ladder and make it visible. I'm looking at Denise, and the Drupal ladder is what we kind of built this concept on.
Oh yeah, return on that.
And that metaphor really carries. So there, you see these well-established, scientific research groups are like, oh yeah, I guess we really don't do a great job of that.
I'm curious if you know about the Santa Cruz OSPO and what's the way that they're actually a profit center for their company or for their university.
Yeah, we don't have any income stream or anything like that. I do know them well, and
I mean, what they're basically doing is seeding startups through their program, and they were required to do that by a famous alum, right?
So I just need a famous alum to require that.
They approached him to say, hey, yeah, you made all this money and you went through us. Would you like to give us some? And he said, yeah, I would totally do that as long as you make it possible for other people to do what I do.
Interesting. Yeah, so I should learn how to ask better, maybe. But yeah, there is definitely a lot of money in this ecosystem. So in terms of just in terms of what we're looking at next, sustainability of these projects is a very common theme. It's not always about scaling up a massive company. A lot of these projects have societal value. They want to continue, but just getting to consistent funding so they can do good work post-grant is something that we're looking at. So we're developing a better understanding of the fiscal sponsorship landscape and how to plug successful groups in there. We're also exploring API based business models for certain types of projects where the code can be fully open source, but there might be a data model, an API to it that can sustain that project. So for example, every air quality index you've ever seen on your phone is just based on parts per million of particles. It doesn't say anything about what those particles are or how toxic they may be. There's actually an open source project at Stanford that has done modeling of this. They want to share it to the world. They want to get to weather.com and have it be on your phone. And having an API-based income from that would be a wonderful way to sustain the project. We actually have one. There's a automated reasoning solver called CBC5. You may not have heard of it, but if you've heard of AWS, so AWS relies on that every day and makes 1 billion calls to their API daily.
Who's having to for that?
They get about $1 million, per year because they have a industry affiliates program. But if they charge 1/10 of a cent per AI call, they'd make them as much in a day in a year.
Yeah.
So
I thought Google established a higher price for that shit.
I mean, we're learning that, so maybe we can talk after. So that's why, right? So I pointed this out. So the other thing is PIs, they get bored and they move on to the next thing. So they built something valuable. To scale to a company, you need somebody who's willing to champion that, keep that going, and push that forward for years.
This is why we did intersource commons, because maintainers are not rabbits.
And so those folks that are doing that pioneer research, they'll build something super valuable, and then they'll kind of move on. It's wait, what about that last thing? So that's why we're trying to get to things like fiscal sponsorships and business models, so that there are people who are the best people at doing that next part, that growth part. So we need to.
I don't think as an industry we do a good job of creating those people. Certainly not through Stanford.
Yeah.
Right.
And another thing that's happening now is we're working with local accelerator groups that are about this, launching companies and so on. So there's this is the pattern at Stanford now. So our School of Sustainability has its own accelerator, and it's meant to get at that translation part for taking your research. You invented a fire retardant that is biodegradable and non-toxic, and it's going to help with wildfires. But to commercialize that, you need something like an accelerator. So I wasn't thrilled about them when I first heard about them, because I thought they were going to commercial too fast. But it turns out that they're much cooler than I thought. And they actually care about open source. So they're about impact, not necessarily revenue. So that's another thing that's happening now that we're just getting into. So that's the Stanford story, but let me know if you have any questions.
I have a question. You hinted at it at the beginning of your slide where you talked about the fact that you're based between big money and big loan.
It makes it harder in some ways.
Right, but there's something in human nature or culture that you've got going there where people are unlocking everything they're doing in proprietary solutions.
That's right.
What have you learned about human nature and culture from that?
I don't know if I can comment on human nature based on that. I would say that there is a culture aspect, though. So there's a couple things happening. One is my university is a pretty permissive place. Like, you're not going to get no's very often. They're comfortable with like letting 1,000 flowers bloom and then just see what happens. And there's another like pervading cultural element, and that is like if you haven't like launched something like in the last week, there's something wrong with it. So that's actually a quote from a former president. So when I started at Stanford, John Hennessy was the president of Stanford. He invented the risk architecture that's something that so it's a strange place.
Do you think it's got anything to do with, you talked about the peer review element and the fact that these people want to make a difference without necessarily making a lot of money?
So we have both types.
Yeah.
I would say the majority are the latter. So I mentioned PyOpenSci and our OpenSci. So that is a big part of our strategy of getting to peer-reviewed software. So we peer review articles. That's standard. But of those articles that have a software component, how often do the reviewers get down on the software? Not very often, or even the data. So that's why, so we're interested in elevating software to a first-class research object that will be recognized and rewarded as scholarly contribution that someone could be promoted for.